Hey everybody, my name is Andrew, and welcome to this episode of the Data Platform. In today's episode, what we're going to do is run through a high-level overview of this project. For this project, we're going to be standing up a Databricks platform. We're going to be using Terraform for this, and we're going to be deploying this through a CI/CD pipeline using GitHub Actions. We are going to put this in Azure, and it's going to sit in a hub and spoke architecture. So I guess we can run through kind of this blog post, and we'll start with the motivation. So the motivation for this is pretty simple. If you are a data engineer, there's a good chance that you're going to need a data platform. And if you are a platform engineer, you're probably going to need to know what those requirements are. And I have been in this field for about 10 years, and I've been a home lab enthusiast for several of those years, and the last few, I've gotten a lot more involved with platform engineering. So I really wanted to kind of help walk you through some of the challenges that I faced along the way, and kind of give you some tips and tricks for how to deploy this. So I think one of the first concepts we need to talk about is just this general idea of using CI/CD pipelines. So uh, for a CI/CD pipeline, we typically want to have some sort of local development, and then we're going to try to just promote that up the chain. So typically through dev, QA, prod. It's a fairly standard pattern, and you can use multiple tools for this, but we're going to use GitHub Actions. Uh, the next concept is this thing called dry programming, which simply means don't repeat yourself. So the basic idea is that we want to try to make this thing as parameter driven as possible, and we want to try to eliminate copy and paste errors. So how we'll structure our code is going to be through using modules and plans. So for our modules, these are going to be things that we would repeat. So let's say, for example, we want to put a virtual machine into multiple environments. Well, what we'll do is we'll code that virtual machine once, and then we'll parameterize it multiple times, once per environment. So this hopefully will help us eliminate our copy paste errors and let it truly be CI/CD. Next up, we're going to talk about building a hub and spoke architecture, which is honestly one of the first things that we'll set up in this project. So, kind of high level, hub and spoke simply means that we're going to have a hub sitting in the middle, and then on the outside, we're going to have multiple spokes. So, the spokes are typically going to be the resources that might sit in each subscription. And these resources, these can be environmental resources like dev, QA, prod, which is what you see on this screen. They could just as easily be team-specific resources. So, teams for the data scientist, teams for the risk analyst, and, various other teams, whoever it is that you're working with. And a pretty common example for how this works is you might have an on-prem data center and a cloud data center. And so you might want to set up something like a site-to-site VPN so that you can connect to your on-prem data center. In that case, what we might do is leverage one set of networking gear in the cloud. And so this could be like your gateways and things like that. And so you might only have, we'll say, like one gateway. And then we could use something like VNet peering to peer into our various other subscriptions and our various other networks, so that we don't have to incur multiple costs at the gateway level. So it's just kind of a cool way of simplifying your setup and reducing some of your costs for things that we don't necessarily need to have multiple versions of. All right, next up is Databricks. So with Databricks, what we're going to be doing is leveraging this thing called Unity Catalog. So Databricks is really kind of a cool way of deploying PySpark and leveraging, basically a decoupled data lake. So you've got your storage within something like S3 or Azure Blob Storage, and then you've got your compute resources. Unity Catalog is a recently GA product that allows you to govern your data lake. And so with Unity Catalog, what we're limited to is one metastore per region. And we can then go ahead and assign those metastores out to our various workspaces. So this is kind of a similar process to what you just saw for the hub and spoke architecture. So we're really going to build off of that same pattern. Now, before we get too far ahead, I do want to talk about pets versus cattle, especially when we're talking about platform engineering, infrastructure as code, Terraform, all that. So when we build this out, you always have to be careful when you're building out your platform when you have pets involved. So pets are essentially resources that would be hard to replicate if they were destroyed. So your pets are going to be typically your data related items. So think data that's in a data lake or data that's in a database. That's usually pretty hard to replicate. Whereas your compute resources, those are usually designed where you can tear those down and spin those back up. So serverless compute, that's real popular. And especially within the Databricks world, what we're going to have to think about is this combination of our clusters that we're going to spin up and spin down. Those will be essentially cattle. But a bunch of what we're going to do is considered pets. So we're going to put some special attention towards how we design our state files so that we minimize our blast radius when we're building this thing out. This is really going to come into play when we get to permission management as well, just because there are different providers between the Azure providers versus the Databricks providers. So we want to make sure that these two Terraform providers play nicely together and we don't accidentally destroy things that we don't want to destroy. One of the final things that I wanted to touch on also was this concept of resource propagation. So kind of what I showed you just a minute ago was this general idea of a hub and spoke architecture where we might have a subscription at the hub, a subscription at the various stages of environment, so dev, QA, and prod. But that doesn't necessarily have to be kind of a one-to-one. We could essentially have multiple resources. I've just got this annotated as resource I through N at each environment. What we could see is potentially a dev, QA, or prod environment, but within those you might have various teams at each one of those levels. And so we'll say like a given team or a given subscription might have multiple lakes, multiple databases, multiple clusters, things like that. So in a programming language like Python, you can think about that as like a nested loop potentially. Terraform looping is a little bit challenging, especially nested looping. So what I want to do is walk you through kind of how I do my mapping within this, because it's easy enough to do, we'll say like for each loops within Terraform, but we really want to make sure that if we add extra items to those for each loops or take those items away, that the statefulness of Terraform doesn't take over and then destroy resources that we do care about. So that was something that I really wanted to touch base on when we're thinking about this concept of pets versus cattle. And then not just the ease of how quickly and easily you can build things within Terraform, but also I want you to be really mindful of how easy it is to unintentionally destroy things when you are scaling out at this level. So with that said, hopefully you guys have fun following along in this series. Thanks, and I'll catch you later.